Hello, friends. So, in this lecture, we are going to learn about the deleting of a node at a given position in a linked list. So, let's suppose we have a linked list, okay, and we need to delete a node, a particular node at a particular specified position. So how we can do that? So we already have seen how we can delete a node at the end of a linked list and how we can delete a node at the beginning of a linked list. So definitely it's a generic approach how we can delete. So both the things will come here. Okay, it's 200, it's 300, and here this is the last node. So the position can be the first position, the second position, or maybe the last position. Okay, so that would be specified by integer position, and we have to go to that particular node and delete the node. But before deleting the node, let's say we need to delete this node. So in this linked list it comes at position third, and if we need to delete this particular node, then definitely we need to update the pointer here, and also we need to delete this pointer, of course. So we need to update this pointer so that it points to this node, right? Therefore, we can delete. So this node will be added in this part, right? I mean, this particular points to this node. So we need to update this 300 to 400 definitely, and then it will be pointing to this node at address 400, and we need to delete this particular link. We need to free this node. Okay, so this way we can delete a node at a particular position. We already have seen how we can delete the node at the first position and at the last position. So let's include all these things in that. And before that, there is one more function we have already seen, that is list length head, that provides us the entire linked list length. Okay, so this comes into handy because we need to check that the position that we are supplying to delete the node at, so this position must be in this range only. That means the position should be greater than 0, of course, because we start from first, and the position should be lesser than or equal to list length. Okay, there shouldn't be 1, it should be less than or equal to list length. Okay, I mean the position should not be greater than list length, because if the list length is 4, so the position can be 1, 2, 3, or 4. But it shouldn't be 5 or something, because if it is 5, there is no node at the fifth position. So this is a mandatory check so that we can identify the position that we are supplying is correct. Okay, so let's begin with this. So let's say our function is void delete at position, and inside that we need to supply the head so that we can traverse over the linked list, and we are also specifying the position of the node that we want to be deleted. Okay, then we have this link length, and the length we need for the linked list, so length equal to list length head. So list length is a function and we are supplying head to that. It will provide us the entire linked list length. We have already seen this function in the insertion videos, or there is one separate video that contains how we can determine the entire length of the linked list. Okay, so we need not to repeat this. Then the mandatory check that we need to perform, that if position is lesser than or equal to 0, or the position is greater than the length. Okay, So this is an invalid position. So definitely we need to update the user that it is an invalid position. Of course, we need not this position. There is no node present in this position specified, and we are forcefully exiting from the entire function. Okay. So this way we can check for if the position is correct. Right now, the position, if it is correct, it could be the first position, right? And if it is at the first position, we need to call this function that we have already seen, delete at begin, and we need to pass the head pointer to that, right? Now the position could be the last position, so else if position is equal to length, that is the last node that needs to be deleted, then of course we have a particular function delete at end, so as we can delete the last node of the linked list, right? So these are very simple steps. Now comes our main logic, that if position lies somewhere between the starting and end. Okay, so if the position starts somewhere in the starting, uh, or the end, we need to traverse the entire loop. So definitely we need a integer to mark the position. So we are setting it to 1. We need two pointers, of course, because one pointer we will be traversing up to this position. Okay, let's say this position, and one pointer should be a backward pointer just back of this pointer. So there should be two pointers, one pointer at the specified location and one pointer at a location just before that location, so that we can update that pointer. Okay, I'll illustrate it, just a second. So there are two pointers, let's say P and pointer Q, and initially they are set to null. Okay, now these pointers are very important. Now let's say while, okay, one of the pointer is our traversing pointer, so let's set it to head first. So let's say Q is our traversing pointer, so it is set to head. Okay, now while the k starts from 1, while k is not equal to the specified position. Okay, so while k is not equal to position, we are going to move the q, of course. So q, first we have p and q, so we will assign p the value of q, and we will move q to one position ahead, that is q equal to next of q, and then we will increment the k value. Okay, so k and q will be incremented accordingly, and p will be one position before q. Okay, so this way we will be moving to, once this k reaches to the position part, that is when k equal to 3, right? So initially P and Q are at the same head, right? And then we check the K is less than the position. So we are moving the Q to the next, and we are assigning the value of Q to P. Okay, so Q is pointing to this and K is equal to 2. Okay, and P is there. Again, 2 is less than 3, not equal to 3. So Q will be pointing to this. Okay, and p will be assigned to value of q, so p is pointing to this and k is equal to 3. Now k becomes equal to 3. Okay, so when k becomes equal to 3, so we will come out of this loop. We have q here and we have p here, right? Now we will do the update of the pointers. So what we will do, in the p, in the next of p, in the next of p we have what, this 300. So we will update it with the next of q. Okay, so in the next of p we will update it with the next of q. So now p points to the next of the node q, and in the, we will be freeing up the q, of course, and in the next of q, or we simply can have the next of q is equal to null, and then we will assign p equal to null and q equal to null. So this is the pointer update part. so that we are just updating the links here and will come out of this function. So this is the basic uh, function to just delete a node at a particular position. I hope this is clear. So we'll see you in the next video. Thanks for watching.